Section 6.1 is about the area between two curves. But before doing that, just look at this little simple problem right here. Suppose you're on the x-axis and this goes from 4 to 6. Then what's the length of this line segment? This nice little red line segment. So the length of this is going to be 6 minus 4 equals 2. So you just take the number on the right minus the number on the left. Well, what if we were on the y-axis? If it goes from 1 to 9, what's the length of that segment? Get some nice color in red here. Then on the length would be 9 minus 1 is 8. So in this case, you need to go the top minus the bottom, and that gives you the area. So when you're going left to right, it needs to be right minus left. For top to bottom, it needs to be top minus bottom. Now for the area between two curves. So if you have two functions, let's say that this one is f of x, and this one is g of x. And then suppose that they intersect right here and right here. And this can be A and this could be B where they intersect. And then find the area between the two. So then the area is going to be, you take the top function minus the bottom function, just like over here. The top one minus the bottom one. So it's going to be f of x minus g of x. And then integrate from a to b. So this needs to be the top minus the bottom. Now, analogous to this, where it's the right and the left. So suppose that you have one function over here on the right, and then that one is going to be E, F, G, H, H of y. And then you have one function that's over here on the left, H, I guess I of y. And then they intersect right here and right here. And this one I'll call C and this one I'll call D. Then to find the area between these two, you need to take the one on the right minus the one on the left. So the one on the right minus the one on the left. So integrate the hy minus the I function. And then this would be a function of y, so it's going to be dy. And then dy, so y goes from C to D. And that integral will calculate this area for you. And now for some examples. So for example number 1, find the finite area. In other words, these functions are going to go on forever, but I don't want infinity as the answer. Find the finite area between y equals x squared and y equals x to the fourth. So first of all, what do those two functions look like? So they actually both look like parabolas. Y equals, clear this out, x squared and also x to the fourth. And I'll start with zoom standard. And my calculator is graphing them both at the same time. So this area between them, this would go up forever, and this area would be infinity. So there's a finite or a small area right in here if you zoom in on the origin. So if you zoom in, then you'll see that there's this little sliver of area and this little sliver of area. So they actually intersect at 1. So if you trace and put 1, you could see they intersect there. They also intersect at 0. And because the graph is symmetric, what I could do is just find this little moon-shaped area and then double the answer, and it'll then give me the total. Oh, the other thing I need to do is figure out which one is on top and which one's on the bottom. So if I go to trace and put in, let's say, a 0.5, then the blue one is on top and the blue one is x squared. And if you move down, the red one is on the bottom and the red one is x to the 4th. So x squared is on top, x to the 4th is on bottom. So the graph looks something like this, little moon shape, going from 0 to 1. And on top, that's x squared. And on the bottom, that's x to the 4th. So then we're going to find this area right here. Oh, so it looks like a banana or moon shape. Anyway, and because there's 2 of them, then double the answer is you integrate from 0 to 1, and then it needs to be the top function minus the bottom function. And then the antiderivative is going to be x cubed over 3 for the first one, and x to the 5 over 5 for the second one. And that gets evaluated from 0 to 1. So don't forget about the 2 because there's 2 of these bananas. And then this is going to be 1/3 minus 1/5 when you substitute the 1. And when you substitute the 0, it's going to be 0. So how much is this? That would be 5 minus 3, so it's going to be 2/15. And then it's doubled. So then the grand total for both sides is 4/15. All right, then what about example number 2? X is equal to y cubed, x is equal to y squared. So this is similar, but y squared, it makes a parabola, and it's saying x is equal to, when you square something, it's always positive. So x is always positive. So it's not over here, it's over here. And it's a parabola, so it's a parabola that's going sideways. So this one is x equals y squared. Then what about this one? Well, my calculator won't graph it this way. If you use Desmos or something, it will. For my calculator, I need to solve for y, so take the cube root of both sides. So y is equal to the cube root of x. So y is equal to math cube root of x. And then that looks like this shape. So that's going to go like this. Oh, but then I suppose that it goes inside of it, or does it go above it? Right now I'm not sure, so I'm going to have to graph this one on the calculator as well. So take the square root of both sides, and then y will equal the square root of x. Oh, good thing I didn't draw it, because I thought it was going to go on the inside. Actually, the red part, which is the cube root function, that actually goes above it just a little bit. And then they intersect. And they intersect right here at 1. Trace 1. So this is going to be at 1. And also the y value is 1. So with this one, I would much rather integrate y cubed and y squared. That's easier than integrating the square root of x and the cube root of x. Now, one other thing before we do the integral is sometimes you can tell from the graph where they intersect, sometimes you can't. So if I can't, then what I would have to do is put them equal to each other. So when does y cubed equal y squared? Then subtract y squared from both sides. It's now equal to 0. You could factor out a y squared. It would leave y minus 1. And then this will give you the answer y equals 0. And this will be the answer y equals 1. So our limits are going to be that y goes from 0 to 1. And we're finding just this little finite area right there, which again sort of looks like a moon shape. Okay, so it has to be the right minus the left. So the right side, that's the black one. So that is y squared. And on the left, that's the red one, and that is y cubed. So it needs to be the one on the right minus the one on the left. So it needs to be y squared minus y cubed with respect to y going from 0 to 1. Ooh, I said y squared minus y cubed, but I didn't write cubed. Okay, there we go. So for this one, the antiderivative is y to the 3 over 3. For this one, it's going to be y to the 4 over 4. And then that gets evaluated from 0 to 1. Substituting the 1 gives us 1/3 minus 1/4. Substituting the 0 gives us nothing. And then this would be 4 minus 3 over common denominator 12. So it equals 1/12. Then for the next example, number 3. So for this one, just set up the integral. Don't actually integrate it. Set up an integral that will find the area of a triangle ABC, where A is the point 2, 1, B is the point 0, 1, and C is the point 0, 5. So I like to visualize what's going on, so I'm going to draw a picture. So 2, 1, so that's point A, and then 0, 1, so that's B, and 0, 5, that's C. So we're talking about this red triangle right here. So of course we could use 6th grade math and just say area equals 1/2 the base times the height, but it would be much funner to use an integral to do 6th grade math. So for one thing, I need to know the equation of this line right here. So this is going to be the top function, and this is going to be the bottom function. For the bottom one, that's easy because it's a horizontal line. Then it's just y equals 1 is the equation for that line. And then for this line, the rise, that's 4. The run is 2. And 4 divided by 2, that means its slope is 2. But because it's going down, it's going to be -2. So the equation of that line will be -2x plus b. And the b is where it crosses the y-axis, so that's going to be 5. Okay, then set up the integral. So it's going to go from, I'm going to be integrating with respect to x, so it's going to go from 0 to 2. And then you need the top function minus the bottom function. So that would be the top function is 2x plus 5 minus the bottom function, which is just 1. And then x will go from 0 to 2. Now, I'm just sort of curious. It said just set it up, but I just got to know, did I do it right? So according to 6th grade math, area is 1/2 times the base, which is 2, and the height, which is 4. So that means that the area equals 4. Now let's see if I did this right. So the antiderivative for this x, right now it's x to the 1, so the antiderivative is x squared over 2, which is actually going to cancel that 2. And then this would be the number 4, so the antiderivative is 4x. So looking at that and looking at that, I have no idea if it's going to give me the right answer. It's going to be embarrassing if it doesn't. So first of all, substitute the 2. So this would be 2 squared, so that's 4, but it's negative. And then this would be an 8. And then minus, when you substitute 0, that's going to contribute 0. So finally, it's going to be 8 minus 4. Oh, good thing. The answer is right, 4. Okay, then just one more. So for example number 4, y is equal to sine of x, y is equal to cosine of x, and then on the interval from 0 to pi over 2. So sine goes like this. It starts right here, starts going up, and then by the time it gets to pi over 2, it's at the highest point, it's at 1. Cosine, on the other hand, starts at 1 and starts going like this, and by the time it's pi over 2, it's at 0. So then we need to find the area between them. So find this area and this area. So right here, they intersect. So for one thing, I need to know where they intersect, because over here, the cosine is on top, sine's on bottom, and then over here they switch. So I need to know this point right here. So in other words, where does sine of x equal cosine of x? What I could do is divide both sides by cosine. And then on the left side, sine over cosine, that becomes tangent. So when does tangent equal 1? I'm pretty sure that's pi over 4. So tangent inverse of 1, divide that by pi, and change that to a fraction. It's 1/4 of pi. Which also makes sense because that would be right in the middle between 0 and pi over 2. So pi over 4. Now the graph is symmetric, so what I could do is just integrate one of them and then double the answer. So it's going to be 2 times, and then I'm going to do this one, the left side. So it needs to be the top function, which is cosine, minus the bottom function, which is sine, and then integrate with respect to x, going from 0 to pi over 4. And then double the answer, and then that will be the total. So it's going to be 2 times, and then the antiderivative for cosine, that's sine. The antiderivative of negative sine is positive cosine. and then evaluate from 0 to pi over 4. So this is going to be 2 times, and then it's sine of pi over 4 plus cosine of pi over 4. And then substitute the 0. So that's going to be minus sine of 0 and also minus cosine of 0. So it's 2 times, and then it's sine, oops, I didn't mean to put sine inverse. Sine pi over 4 plus cosine of pi over 4. Sine of 0 is 0, and cosine of 0 is 1, so minus a 1. And so then the grand total, even with the 2 times it, is 0.828.